This is the 30, 60, 90 degree triangle. It is a special right triangle as where if you know one side, you will be able to find out the rest of the segments. So, the shortest leg would be x, the hypotenuse would be 2x, and the longest one would be x root 3.
Oh. Okay, so now we're going to be talking about the different shapes that the 30, 60, 90 degree triangle applies to. So then the most important one is the equilateral triangle. Why? Well, if you look carefully, the equilateral triangle is just two 30, 60, 90 degree triangles. Because if you cut it in half, then the degrees up here is cut in half, so then it would be 30 degrees, and these two would be right angles, as you can see, 30, 60, 90. So then, how would you find the area of the 30, 60, 90 degree triangle here using the side length of the equilateral triangle? Well, say that the side length of the equilateral triangle equals x. So then, if you knew that, because it was cut in half, this would be x, the smaller leg would be x over 2. So then, you do x over 2, so with the formula that Ben provided before, this would be x root 3 over 2. So then now we know this, so then now we just apply the formula for just the basic area for a triangle. So then it would just be base times height over 2, which would be x root 3 divided by 8. And also, this is proven, you could also find the equilateral triangle by doing this. And it has been proven it's x squared root 3 over 4 because you just multiply base times height. So then the next shape that we're going to be talking to, that 30, 60, 90 degree triangle applies to, is the hexagon. If you look carefully, the regular hexagon is made if you put a center and then connect every single vertex to the center. What do you get? 6 equilateral triangles. So a regular hexagon naturally has 100 degree, and every single angle equals 120 degree angle. And if you cut them in half, equals 60 degrees. So then that's pretty much saying, with the previous formula, you can just use that and then multiply it by 6 to find the area of a hexagon.
You know, I had a applications.
Whoa!
Okay guys, as you can see, this is my Death Star 3.0. This is a rebel. Mr. Darth Vader has gave me a mission to take care of him. Now, according to his calculations, actually my calculations, the Death Star is 100 root 3 miles above the surface of the moon, and the direct distance is 200 miles. This distance right here is 100 miles. When I look at this diagram, I think of two things: Star Wars and 30, 60, 90 triangles. 30, 60, 90 triangles, you ask? Well, if you look at it, it reminds me of a 30, 60, 90 triangle. If you make x equal to 100, then 2x is 200, and x root 3 is equal to 100 root 3. That's really hard math right there. Now, knowing that, the shortest angle, which is the 30 degrees, corresponds to the shortest side, which is 100. So, knowing the properties, I can conclude that the angle I need is 30 degrees in order to fire the orbital cannon and take care of this guy.
Yay!
Let's try.